So in this video, I will show you how to find the equation of a plane if a point on the plane and a normal vector is given. So normal vector sometimes is also known as perpendicular vector or orthogonal vector to the plane. So you can see in this is a formula just like I mentioned before in the introduction. So you can see that in example 1, find the equation of a plane that passes through the point 0, 1 and -7. So this point will be our P node, which is the point on the plane. And perpendicular, you can see that the other keyword here is perpendicular to the line that has a parametric equation of x, y and z. So we will get the normal vector from this parametric equation. So how are we going to get the normal vector from this parametric equation? Sometimes you say, why we are going using this one? Because the question is already mentioned that this is the parametric equation is perpendicular. If you remember, n refer to the normal vector or perpendicular vector, which is perpendicular of normal to the plane. So this parametric equation is perpendicular to the plane. So this is our n. So from where we'll get the n? We'll get from the a, b, and c. So in this case, our a, b, and c, or the normal vector will be the value of a, b, and c, where a is 4, b is -1, and c is 6. So 4, -1, and 6. So since we have the normal vector and we have the p node, so therefore you can see here is the formula. Dot product of n with p minus p node equals to 0. So this is our n vector, a normal vector, which is 4, -1, and 6. Dot product with x, y, and z. Where x, y, z come from? Which is the p. P is the variables of x, y, and z. P minus p node. Our p node, the first one is 0. So means that x minus 0. Then second variable is y minus our second value is 1. And third z minus -7. Our coordinate of z in p node is -7. So from here, we expand using the dot product. So we will get the equation of the plane. So in this first example, the normal vector is in parametric form. So we can get from A, B, and C. Let's look at the second example or the first exercise one. Find an equation of a plane that orthogonal. So sometimes it's using the words perpendicular or orthogonal to the line that has a Cartesian equation. So this is a Cartesian equation. And contain the point 2, 4, and -1. So which means that this will be our P node. So where to get our normal vector? The normal vector is the value of ABC. In this case, in the Cartesian equation form, so the ABC is 3, 5, and -2. This is Cartesian equation, where the ABC is on the denominator, which is 3, 5, and -2. So if you still remember, for parametrics equation, the general form is x is equals to x naught plus t times a. Y is equals to y naught plus t times b. And z is equals to z naught plus t times c. So you can see that ABC actually is the coefficient of t. So you can see t. Whereas in the Cartesian equation or symmetric equation, sometimes known as Cartesian equation, or symmetric equation. The formula is x minus x naught over a is equals to y minus y naught over b is equals to z minus z naught over c. You can see that a, b, c is in the denominator. So in this case, that's why I'm using 3, 5, and negative 2. So using the formula, the dot product of n with p minus p naught. So our n is 3, 5, and negative 2. Dot product with n minus n naught. P minus p naught. So p is x. X minus the coordinate of x is 2 minus 2, comma y minus the second coordinate is 4, comma, and finally negative 2 minus, oh, it's not negative 2, sorry, it's z, z minus p naught is negative 1. The coordinate of z is negative 1, so put a bracket, negative 1, close the bracket. So from here we have 3, 5, and negative 2, dot product with x minus 2, y minus 4, and here is z plus 1. So we can try to find the dot product. 3 times x minus 2. 3 times x minus 2 plus 5 times y minus 4 times y minus 4. And finally, negative 2. Negative 2 times z plus 1. And don't forget, sorry here, actually this one is equals to 0. So sorry about that. Suppose that this one is equals to 0. So in front here, we can erase the equal sign. So here is equals to 0. This equation actually is equals to 0. So expand 3x minus 6 plus 5y minus 20 minus 2z minus 2 is equals to 0. We can simplify here. 3x plus 5y minus 2z. So negative 6 minus 20, negative 26, negative 28 minus 28 is equals to 0. So here is our answer for exercise 1. This is the equation of the plane. So the first scenario is the most easiest scenario, where the n vector we can straightforward get the normal vector and the p naught. Later on, for the second video, for the next video, we'll look at the second scenario where a point is given, a point on the plane is given, a point and a line on the plane is given. So in this, in the next video, the normal vector is not given. So we need to find the normal vector.